This lesson's all about ladder logic, which is probably the most used language of all of them, especially in sort of older systems, mainly because there just was the lack of any other languages available, because lower level PLCs tend to only offer ladder logic. However, it's probably the easiest to understand and it's the most transferable from electrical drawings or working in maintenance. Typically, ladder logic is what you'll encounter the most. However, structured text, which we'll come on to later, is also something that there is a lot of out there now. So what is ladder logic? Ladder is given its name because it looks like a ladder. It doesn't really look like a ladder in Siemens so much, but we have a left-hand rung, which is your power rail, and this really, really small right-hand rung, which is the end of your logic for this network. Networks are ways of isolating code between different sort of functions, and I would encourage you to use networks to segregate your logic. You'll see as we sort of put stuff down that networks are important. You can't just write everything on one network, but equally, where things can be grouped by network, we should group them. And then this main bar here between the two rungs is where your actual execution takes place. Ladder always runs from the left to the right and then the top to the bottom. For example, we would execute network 1 first, evaluate this instruction, and then do this instruction. If I put a branch in, the logic flow would be this instruction first, then this one, then this one, then this one, because we always go left to right and then top to bottom. So because we can go all the way from here to here on this branch, we would do that first. And then as we move down the logic, we'd come down this branch and do this. So let's have a look at a network that's a little bit more complicated. So I'm going to put one of these down and a coil. I'm going to call this one bulls B1 and bulls B2. These aren't anything in particular, they're just variables, so I can demonstrate how it looks. And then here I will create a branch. So I created that by clicking the down arrow when I was here, putting my instruction in, and then clicking the up arrow to close the branch. And I'm going to call this one bulls B3. Now this time, even though we can go straight across, because this here is a branch up, we will do this instruction and then this instruction. And then we will continue along with the branch. So not quite the same as a open-ended branch. So when we had, if we had this, for example, which is a bit more complicated, and we'll call that one bulls 4, and then bulls 5. This time we would go this instruction first, this instruction, and then we would close the branch and come back up and then run across, execute this instruction, and then we would come back down this branch and check this instruction and then this one. Now, for something that we're actually displaying on the screen right now, it largely doesn't matter about the order, but it does matter about the order the second that we change this to B2. Because now what we're doing is we're setting this one and then checking the same one here. And this actual type of programming is not recommended. What is recommended in this case is to completely segregate this down to another line. So you force the execution flow to ensure that it's finished with B2 before it checks it here. And I'm talking about checking and setting, like we understand exactly what these instructions are, but people who are brand new may not understand even what we're looking at right now. So this here is a normally open instruction. So unless it's set to true, you cannot execute anything through this instruction here. So if B1 is false, we'd stop here and everything after it would be false. It's important to understand that we still scan the logic. It's not a case of, oh, this gate isn't shut, so therefore we don't do anything after this gate. That's not true. If B2 was set to true, and this is false, and B3 is false, B2 gets set to false. It's not that it doesn't get scanned. It still gets scanned and it gets set to false. So this is a coil. And if the preceding logic to a coil is true, then the coil becomes true. So B2 would be set to true if this line here is true. The only way this line can be true is if B1 is true or B3 is true. Anything else would result in B2 being false. And then we would move down to network 2. And on network 2, we would check B2. And if it's true, B5 would become true. So effectively, what we're doing is saying if B1 or B3, and it's an or because of this branch here, if B1 or B3 is true, then B2 and B5 become true. And the B5 and B2 are linked because of this B2 here. And again, we have no specific application for this, so there might be the question of why would you do that, but we don't know where B2 or B5 is being used elsewhere in the project, so there might be good reason as to why we're doing this. So we've looked at an OR gate here, which is what this is. Let's move this one up to this line here. And you'll notice that TIA-Portal just removes the branch. But now we have an AND logic gate. So if B1 and B3 are true, then B2 becomes true. And let's go online and actually demonstrate this. So now if I set B1 to true, we can see that it displays the fact that it's true by changing the object to green and showing that there is a throughput of logic. And we're now stuck at B3. Everything after B3 is false. If we set that to true as well, we can see that B2 becomes true, which also turned on B2 down here, and then set B5 to true. And if we just roll back to our OR gate that we had set up before, we can see that right now both of these are true, and therefore B2 is true. If I turn off B3, it's still true because B1 is true. And we can also see that this branch here, although this is an up branch, it's still true. So if we had anything coming off of this down at this level, it can travel down as well. That's a really important thing to sort of keep in mind, that up and down branches or open and closed branches, information can travel both directions on there. And if I go ahead and turn off B1, we can see that B2 gets turned off here and also down here. So that's a really basic introduction to ladder logic. If you look below this video, there's quite a few videos looking at particular areas of ladder and sort of example setups and typical things that we would come across in ladder. And then what we will do is, as we progress through this section for programming languages, we will look at these examples in other languages as well. So go ahead, go through the lesson and have a look at all of the different examples. And if there's anything in particular that we want to discuss, just drop a comment on this lesson and I'll see if I can put something together to help explain that better.